Hello friends, in today's class we are going to talk about LRU, least recently used implementation. So welcome here, and we are talking about LRU implementation, and the first implementation is the counter implementation. Okay, so the counter implementation, every page entry has a counter. Okay, and every time page is referenced through this entry, copy the clock into the counter. Okay, so whatever the clock value that will be copied here in this case. Okay, so that value will be copied in this entry. When a page needs to be changed, look at the counter and find the smallest value. Okay, look at the counter and find the smallest time in this case. And here in this case, we can maintain the list, though search is required. Search table is needed in this case. Okay, so one is your counter implementation, and the second implementation here in this case is the stack implementation. Okay, stack implementation, and keep a stack of page numbers in double linked form. Okay, so we are maintaining a doubly linked list. Okay, not a single linked list, we are maintaining a double linked list. Okay, when the page is referenced, move it on the top. Okay, so when you are moving it on the top, we may need to we may need to update a pointer. Okay, so just as a good question, that how many pointers, how many pointers required to be updated? Pointers required to be updated. Okay, but each update is more expensive here. Say no search is required. LRU and OPT. LRU means least recently used, and optimal algorithm are the cases of algorithm that don't have Bilet's anomaly. Okay, so we have already seen that FIFO is having Bilet anomaly, but it does not have a Bilet anomaly. So counter implementation is a simple one, and we need to do the linear search, and the best case can be the binary search. And stack implementation is this. Let's try to make you understand this stack implementation. So suppose 4 is referred. Okay, 4 is in the stack, then 7 is referred next. 4 and 7 is there, then 0 comes, so now becomes 0, and the 0 is the most recent one. Now here when the 7 will come, then what will happen is when 7 will come, 7 will go on the top. So this in the stack, this will become 4, 0, and 7 will be on the top. Okay, so and then there is a 1. So what we are going to do is this, that we have a stack, and then that stack, what it will become, 4, 0, 7, and then 1. Which one is the most recently and least recently used? So most recently here in this case is 1, and 4 is the least recently used right now. Okay, now here 4, and then what we are having is 1 is already there. 0 is a hit, but now what happen in this case, this 0 will become most recently used. Okay, so now this 0 will become most recently used, and for this 0 will go on top, so it becomes 4, 7, 1, and 0 will be on the top. Then you have a 1, so now 1 will go on the top, it will become 1, 0, 7, and then finally 4. Then we have a 0 and 1, then we have a 2. So most recently used will become 2 in this case. Okay, so it will become 1, 2, 3, 4. So it will become a 5 entry, 1, 2, 3, 4, 5. So it will become 2, 1, 0, 7, and then 4. Okay, so this is that 2, and then again 1 is there, so 1 will again go on the top. 1 will again go on the top. It will become 1, 2, and then 0, then 7, and then finally 4. Okay, so 0, 1, and then we had got 2, then again I got 1, and then again there is a 2. So this 2 will give you this answer, that in this case it will become 2, 1, 0, 7, 4. 2, 1, 0, 7, 4, stack before A. Okay, stack before A. Okay, a slight mistake in the arrow, means A is not here, A is here, and this B will be here. Before this instance, stack is this. Okay, it is not pointing to this. Now what will happen is, after then we can also say that if 7 is coming, what will happen, the 7 will altogether will go up. So the final answer will be, in this case, will be 7 will go all together up, and then it will become the rest of them 2, 1, 0. 2 is there, okay, 2 is there, and then 1 is there, and then 0 is there, and then finally there is a, okay, so 7, 2, 1, 0, and 4. Okay, these are my some diagrammatic error in this. Okay, so they are pointing to this empty location. Okay, here or here you can say. Okay, so that is your stack based algorithm for LRU implementation. Okay, so that's all for this discussion. Thank you.